Right then, this is possibly the nerdiest game on the planet. It's TIS-100 by Zachtronics, and it's definitely a game for nerds. I've tried to reset it all so that it's all back to default, and I don't think it works very well. This game is in early access, so I'm not really quite sure what's happening there. Anyway, this is a game about assembler. I can't believe I'm saying this. This is a game about assembly language programming. It's actually a puzzle game, and there's a manual with it. And what it is it's a let me just switch this over. It's a game about a fictional computer, and let me just turn that down so I'm not deafening myself. Yeah, it's a game about a fictional computer. It's a puzzle game. You have to try and get through each step and basically repair nodes in the computer, and you do that by programming it. And it's quite interesting. It's a really interesting game concept. It comes with a big old manual that you've got to read, that's quite entertaining, and it's got some clues to the puzzle as well as information about how to program the computer. Now, what you do is, this is the initial screen. Like I say, I don't think all of these are shown when you first start the game. I've tried to reset it, but I'm not sure that it's worked very well. But you'll have this one available to start with, and you just go to create new program, and it takes you into here. And is that right? That's not the normal one. Maybe it's changed. It might have done. The game is in early access, so there's a lot of updates. Anyway, okay, that's cool. I can live with that. Let's just delete all this code. We don't need that, and we've got to read a value, so it tells you up here what you need to do, right? And these are the in values, and these are the out, what are the expected out values. And when you run the program, it displays the out values down in these columns, in these empty columns. What we've got to do is we've got to read the value from in.x and write the value to out.x. So in.x is up here and out.x is up here. And we've basically got to write a little program in each of these boxes to move the value from here to here. Okay, it's fairly straightforward, and we've also got to read a value from in.a and write the value to out.a. So in.a is over here and out.a is down here on the bottom right, and we've got to go down again, but one of the nodes is broken. Okay, and every so often there's a broken node, and you can click on it to debug it, and it gives you some information about the kind of the mystery behind the computer. So that's quite interesting. So the essence of programming this computer is pretty straightforward. You've only got a few commands that you can do, and you can get onto conditionals and loops and stuff, but for the moment we're just going to do a really simple command, and we're going to move or mov, and basically each of the nodes here has got 4 ports, and the port at the top is called up, the port on the left, this one doesn't have one, it's called left, the port on the right is called right, and the port on the bottom is called down. So we've got up, left, right and down. And so if we want to move something from the up port, we do move up, and then we say where we want to do it. Now for the time being, I'm just going to move it into the register. Now we've got one storage unit in here, and that's called ACC, and that's the only place we're allowed to store things, and we'll come on to more for that in a minute. Then anybody who's familiar with debugging will know what these things down here mean, but in case you don't, stop is obviously stop the program running. Step is go one cycle at a time, and we'll use that in a minute. Run is to run the whole program, and fast is to run the whole program really fast, and we'll show those in a minute. The we're going to step and just see what this does. Okay, so we're going to step once and the program started. Okay, and in.x has been set to 80 and in.a has been set to 54. Okay, so when we run this instruction up here, it should move whatever's in in.x into ACC, right? And it's actually taken another step to load up the portion of this node. We step again, and then that's moved it from up into ACC, and you can see there that ACC is now set to 80. We're going to stop now because that's not really going to help, because we're going to get stuck there. What we really need to do is we don't really need to store this, do we? We just need to put it into the down port, and we can do that. We can move things straight from one port to another, so we can move up, down, and that'll move whatever's in the up port to the down port. And we can copy this with Control C and paste it in here with Control V and paste it here with Control V, and then every time we run this program, it will move whatever's in up to down, and this line will move whatever's up and down, and so on and so forth. With a 1 or 2 line program like this, every time you run it, it goes through each step in turn and then starts again at the beginning. You don't have to tell it to go back to the start, which is quite cool. So if we do this, and step it, we'll see that it's moving 80 down and 80's out now. And if you can see over in the out.x column here, we're matching the expected values. Okay, if we run it, it's going to do all of them and they're going to match, right? Because we haven't done anything with out.a yet, and because the program's still running, we're going to need to stop it. If we hit the fast button, it runs it really quickly to the end without going through each of the steps, if you see what I'm saying. Okay, right, so that's pretty straightforward. Now what we've got to do is we've got to try and deal with this now, because we've got to move in.a down to out.a. Now same thing applies. We're going to move up into left, right? Left indeed, correct. And then what we're going to do is, when we've got a value on the left port here, we're going to move it down, and then we're going to move up to down, and then we're going to move up to right, and then we're going to move right to down. And I'm putting commas in here. I don't think you have to. Let's just check. We can do that, and it does tell you if there's a syntax error. If we type in down here, see it says invalid register down. Okay, so if we make a mistake, it will highlight it for us. And now what's going to happen now, if we step through this, is we'll load up the registers. We'll load up the in.x and in.a, and on the next step we'll move that around. Okay, so in.a is going to finish quicker because it's got less. Okay, and we've got stuck somewhere. Move, and that's totally my fault, because I can't tell my left from my right, because we need to move what's in the right port here. Now we can use this as a good example of an error and how the machine stops working properly, but it doesn't give you any clue as to what's going on. So if we step through this again, load up the in.x and the in.a with the next step. So we've got 80 in the up port here, and we've got 54 in the up port here. Okay, make the next step. And what we did here was we moved up, so we moved 80 to down, and we moved up to left, so we moved 54 to the left port. Now when we step again, this will work, and this will move this 80 down, right? No problems at all. But nothing happened here, and actually the machine is completely stuck now, because it's got a value in this port and a value in this port, and none of the program is moving those values through the system. And so when all these ports in this chain are full, it will stop running. But obviously our part on the left hand side is running, and so it's just this bit's jammed over here. So let's change that to, and I will learn my right from my left playing this game at some point, and let's try that again. Okay, and this time 54's moved into the down port there, which is exactly what we want. Let's try running that and see what happens. And look, we're still stuck, right? Because I still can't tell my left from my right. We want to move what's on the left port, and we want to move it down. So let's try that again. And as you can see, it goes through and it tells me how many cycles we used, the nodes that we used, and how many instruction counts we used. And this gives you a score. And in theory, you can improve the efficiency of the code so that you get a better result. So let's return to the segment list, and what we should see here is I got nominal. So that's a nominal result on self-test diagnostic. It took 83 cycles, 8 nodes and 8 instructions to complete. Right, so that's the theory of the game. Now excuse me while I have a bit of yogurt. What it then gives you is it gives you some more programs to solve. So I've already solved this one, but I'm going to go back to it. I'm going to create a new program. I'm going to look at this one as well. So what we need to do on this level is we need to read a value from in.a, we need to double it and write the value to out.a. Now in.a is at the top here in the middle, and out.a is down the bottom here. We've got a couple of communication failures, and let's have a quick look at this debug. Continues to baffle. Chatted with Bernie at IBM, and he says it sounds like something they'd DONA come up with in the USSR, but then why is the manual in English? Right. Okay. So we need to double a value now, and there's no multiplication in this computer at all. The only way we can multiply things is by repeatedly adding them together until we get to the value we want. Now in this case it should be fairly straightforward, because we only need to double it, so we only need to add it to itself. Now it helps now to have a look at the manual, because there's a few commands, and I'm going to try and bring this up. I don't actually sure how it's going to show up on the screen, because you're going to see my desktop, which is fine, and the PDF is here, and basically you can read through, and some sections are highlighted to give you clues as to the mystery behind the machine. But what we want is the information about the instructions. So the instruction set starts here, and there's a few ones we need to look at, but actually I will come back to those, but add is our key one. And when we do an add with a source value, so that could be a port or a register, what happens is the value of source is added to value of ACC, and the result is stored to ACC. Okay, so if we do an add 16, we'll get the value 16 is added to the value in the ACC register. If we add left, it takes the left port and then adds it to ACC. Okay, so add is what we need in this case. So let's go back to the code. So we want to get a value first, so we know how to do that. So we're going to move up, and this time we're going to put it in ACC. Now the registers, they're a standard part of a computer that allows it to store values at the very lowest level. They're not memory, they're part of the processor, and it's one single value at a time. This computer has 2 registers, ACC and BAK, and you can only directly access ACC. If you want to put something into BAK, you have to put it into ACC first. So ACC is really the only thing we've got to work with. Now, so what's going to happen here is we're going to move whatever's on the upper port into ACC, okay? And then what we're going to do is going to use the add command, and we're going to do add ACC. And what that will do is that'll add the value in ACC to whatever's already in ACC. Okay, so let's try that and see if that works first, because basically we've got our in.a is 11. We want our value that we then trickle down to the out.a to be 22. So let's step over let's get the program ready and then load up the port, and then we're going to do move up to ACC, so that's going to move 11 into ACC, and then we're going to try and add ACC to ACC, okay, and that's going to give us 22, so that's the value we need to then move down. So that's a nice simple bit of programming there that we can use to create our value, and that's doubling. Obviously if we wanted to do it, if we needed to triple it to meet the requirements of the program, we could add it again, and we'd need to start creating a loop then if we wanted to go any more higher than a kind of triple. Once we've got that value in ACC, we obviously need to move it into the down port so we can shuffle it out onto out.a, and then we need to repeat a lot of our similar program that we did before, just to move the value down into this through the system, move up, and we're going to move that onto the right port, and then we're going to move what's on the left port and we're going to push that onto the down, and that's going to put that out to A. Now if we step over this a little bit and just check that the first one ends up in the right place, so we've got 11 in the up port, we're going to move that into ACC, we're going to double it, and we're going to move it down, and then it's here. Don't forget there's another entry on the port up here already, so that's okay. Move that down, move that right, move that down, and we're good. Okay, so let's run the program now, and that should finish. Now I have to say that this is quite possibly the nerdiest game I have ever seen in my life, and I'm not much of a programmer. I do understand assembly language a little bit, and I just found the game really interesting. I totally recommend you picking it up because it's only £4.99 on Steam. It is in early access though, so some changes are being made to the program still. So it is still a work in progress. If anybody's interested, the game's by the same company who made Infinity Factory, which is a game that came out, an indie game that came out early this year or last year, which is a puzzle game as well. So it's giving me my statistics, and we're going to return to segment list. So my signal amplifier got nominal. Okay, right, we're going to move on to the next one, and as you can see I've already completed that, but we're going to go through it again. The requirement here, let's have a look at our debug node first. Interesting, it looks there's some kind of static memory in this thing, encoded something or other. Interesting, right. In this one, the differential converter, we need to read a value from in.a and in.b. We need to write in.a minus in.b to out.p, and we need to write in.b minus in.a to out.n. Now that is more complicated than it sounds. Let's and there's a couple of ways we can do this. Let's just try and work out what we're going to do. So the first thing we need to do is we need to move in.a and in.b into the node. So let's do move up, and we probably need to store those. So let's move them into ACC, and let's move up into ACC. Yep. Okay. And if we look at the manual, we can see that there is, as well as the add command, which we used in our last program, there's a sub command, and it does exactly the same thing, except it subtracts the value that you pass to sub from whatever's in ACC. Okay, so what we need to do now is we need to get to out.p, we need to do in.a minus in.b. Okay, so let's, for the time being, we are going to move the value we've got in ACC to the left port. Okay, what's going to happen here is that we then need to sub right, yeah, and that's going to subtract whatever's on the right port to whatever's on whatever value there is in ACC. Okay, seems fairly straightforward. So let's try that with the step command and see what happens. So the ports are all loaded up and we're going to run our commands. So we've got 26 in ACC and we've got 10 in ACC over here. Okay, now next step, this hasn't done anything, right? Because there was nothing on the right port when it ran. Obviously we moved ACC into left here. If we step again, we're going to go back to the beginning of the program, okay? And actually we've got our value that we need in here, right? Have we? 16 is out.p. Okay. So that worked okay. So that's kind of interesting. So now, excuse me while I eat my tea. We have got to move our value in ACC down. So let's stop the code running. That's a key. There's a key value, right? That's what we need. ACC down, and that's gonna. Then we can use our normal code to trickle the what's on the up port to the down port, and the same again to put that out onto P. Okay, that should work okay. The trouble is here that we have lost our initial value and we need to do a subtraction over here as well to get the value out. Okay, so what we're going to do is we're going to use one of the other commands, which is called sav, and sav saves, I think it saves the copy of saves whatever's in ACC to the backup, and this is how you get things into the backup register. Okay, so what that will do, let's just step over it so we can see. We're going to set up the ports, and we're going to move 26 into ACC, so you can see 26 is in ACC. And then when we do sav, it's going to copy that value into the backup register, right? So that's all good. And then we can do sub write, which is going to give us our value in ACC, and that's going to move that down, and then we've got 16, and that's heading out, and 16 is the one we want to be in out.p. What we've got to do as well though, let's stop the code running, we've got to get out.n, and out.n is in.b minus in.a. Now let's just step through again. What we've got is we've stored our value that we had in here in ACC, but we've also stored it in back, right? So now we've got this value that we want to send down, but we also need this value, so then on this side we can do this to the a similar subtraction. So we will, let's stop the code running. What we need to do is we need to get back into ACC, and you do that with the swap command, SWP, and that will move whatever's in back into ACC, and then we can move ACC into the right port. Yep. Okay. Now we need to do these things in a similar time, because otherwise everything's going to get out of sync, and as we go through the code, if it's not in sync, we'll start having the wrong value here or the wrong value going across either way to do our subtractions. So what we need to do is we need to we do need to move ACC down there to start with, right? We do need to swap this back, and then we need to grab this. So we've got our value in ACC here. We've moved that left. We don't need to do, oh no, that can't be right, can it? Let's, no, we don't want to move it down either, because that's not going to help us. Bear in mind, I've already solved this puzzle, so you know, what can I say? Okay, what we need to do is we need to try and work out a way that we can get this. So we've got ACC right over here, okay, but by the time we've run 1, 2, 3, 4, 5, 6 instructions, we'll have run this twice, right? We'll have run it at least twice. So we're going to use an instruction called NOP, which basically does nothing. And then at this point here, we are going to do, we've got our value in ACC, so we're going to do sub right, and then we're going to move ACC down. Let's see what happens. So we've got our value that we want in here in 26. We're going to save it into the backup register, and then we're going to do subtract to give us 16. We're going to move that down to the down port. We're going to swap the values. Going to move ACC right. Now sub right's not going to work, I don't think. No, see, and the program's completely got stuck now because oh no, it hasn't, because it's because I'm doing the wrong side, isn't it? What an idiot. Let's sub what's on the left port. Let's step through again. Sub left, we get minus 16. Move ACC down. And what we need to do is stop this. Let's just move these down when they're done. And let's try and run that and see what happens. And there we go, we're getting all the correct values. It's not very efficient, but it does the job. And there we go, we finished it. Test passed, return to segment list. Now, the whole game continues on like this. It's really interesting, and like I say, I totally recommend you pick it up. It's quite interesting and an entertaining game and an interesting concept, if nothing else. I really like it. I've only got through a few of the segment, fixed a few of the segments. I'm finding the whole game really interesting, but it's quite difficult because I'm not a programmer at all. If you like this video, I'd really appreciate a follow on Twitch. You can follow me on Twitter as well at UnshapedAdrian. Check out my YouTube channel on youtube.com/UnshapedAdrian. And yeah, please let me know if you enjoyed this. If you want some help, I might be able to provide it, might not. Yeah, thanks very much for watching. Cheers.